Great seeing you here again. My name is Ludwig Koster, founder of the Koster Academy. And in this video, I will talk again about some interesting subjects that are part of our math survival guide. In this video, I will talk about the intersection, but now we are going to look at a special case, the intersection of two lines, but we have one line using the point slope expression and the other line is in the standard expression. We already looked at intersection of lines when both equations were point slope or both equations were in fact the standard form. So now we are going to look at a hybrid solution. We have those two different equations of two lines, and we want to find the intersection point. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look at the intersection of those two lines. And we have one line that is given in the standard form, ax plus by is c, and the other line is given in the point slope expression, y is mx plus k. So when we see the different lines, we have them in the x and y axis system. We first have a1x plus b1y is equal to c, and then we have y is n2x plus k2. We have the first expression, a1x plus b1y is equal to c1, where we have a slope of m1, which is equal to minus a1 divided by b1, and in our example, we have a negative slope, so a1 and by are in fact both positive or both negative. Y is n2x plus k2. This is the second expression. We already know here that the slope is n2, and when we have different slopes, then we know that there will be an intersection point. So we know that m1 is not equal to m2. Now we have to find the intersection point, and we are going to do that using the same example. We start by replacing y in the first equation, because we already have the expression y is n2x plus k2, so we don't have to make our lives more difficult. So we replace it in the first expression, so we have a1x plus b1, and here we replace y by the expression of the point slope expression of the second line. So we have here m2x plus k2, and that is equal to c1. So now we have only one variable, we only have one unknown, which is x, and we can write this in a different way. So we have, when we multiply the equation between the brackets, we found a1x plus b1 m2x plus b2 k2 is equal to c1. We bring everything with x to the left-hand side and all the rest to the right-hand side. So this gives us the expression a1 plus b1 m2 times x, because both of them have x in common, so we can write it as this. And we see on the right-hand side we find c1 minus b2 k2. And in order to find the x value, we now just have to divide both sides by a1 plus b1 and 2, and we find that x is equal to c1 minus b2 times k2 divided by a1 plus b1 and 2. Now we continue with the same system. We replace x in the point slope expression, and we have the second expression. So we have y is m2 times x plus k2, and x is c1 minus b1 k2 divided by a1 plus b1 and 2. And we now know x1 and y1, and we put them in the equation to control. So we find x1 c minus b1 k2 divided by a1 plus b1 m2, and y1 is in fact m2 multiplied with the x value of x1 plus k2. And we have to control now if this is effectively the solution. Let's have a look at an exercise. Here we have two lines, we have two equations. The first equation, 3x plus 2y is equal to 6. And the second equation is y is x plus 1. We already see in the graph here that they have different slopes, so we already can conclude basically that there will be an intersection point. First equation, 3x plus 2y is equal to 6. So we find that m1 is minus 3 halves. The second equation is y is x plus 1 and m2 is equal to 1. So we know that both slopes are different and we will have an intersection point. Now, first of all, we want to find that intersection point. I refer to it as x1 and y1. There is a 2, but it should be a 1. Anyway, we find 3x plus 2 and we replace the value of y in this expression. So y is x plus 1 and it's equal to 6. We multiply and we find 3x plus 2x plus 2 is equal to 6. And based on this, we can say that 5x is equal to 4. And finally, x is equal to 4/5. With this value, we can put it in the point-slope expression, and we can find the y value of the intercept. So we have those on the graph already, and we can say that x1 is 4/5. We put it in the point-slope expression, which gives us y1 is 4/5 plus 1, which is equal to 4 plus 5 divided by 5. And we find y1 is 9/5. Now we have the solution, we have the intercept, but now we have to verify, is this correct, yes or no? So the control, we put those numbers in the first equation, and we say that 3 times 4/5 plus 2 times 9/5, is this equal to 6? We have to prove this by completing the calculation and comparing the left-hand side with the right-hand side. Left-hand side, we find 12 plus 18 divided by 5. And when we control this, 12 plus 18 is 30 divided by 6. So basically, we see that left-hand side and right-hand side are both equal to 6. So that was it for this video. We finished the hybrid problem. So we are mixing the basic equation or the standard equation with the point-slope equation. And we found, again, a way to calculate the intercept. That's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.